Products of array except self. Given an integer array nums, return an array output where output of I is the product of all elements of nums except nums of I. So our input for this problem would something like this: an array nums with 1, 2, 4, 6, and output would be 48, 24, 12, and 8. Let's try that out on the paper so that we can understand properly. So nums is equals to 1, 2, 4, 6, and then output should be, for 1 it should be 2 into 4 into 6, that is 48. For 2 that should be 1 into 4 into 6, that is 24. For 4 that should be 1 into 2 into 6, that is 12. And for 6 that should be 1 into 2 into 4, that is 8. So let's start with the first approach. The very intuitive approach which comes to our mind is, let's try to find out the product across all array and exclude the element of interest. So let's say we'll have two for loop, one for loop for fixing an element, let's say I, that telling that okay, you need to exclude me, and the second for loop would be to iterate through another elements apart from I and then find the product, and then we'll keep on finding the product and store them in a result. So let's try that out. We'll first try it out on a compiler so that we understand what goes inside. So let's start. We have nums as 1, 1, 2, 4, 6, and then we will hold a result in res. So the brute force approach is maintain two for loops, one for fixing an element, telling that okay, you have to exclude me for I in range length of nums, and then we'll have variable to store the product, which will initialize with 1, and then another for loop for j in a range length of nums to find the product. Now we have to exclude I. So if I not equals to j, then and only then we'll find the product. The product will be nums of j. So now res dot append should be product, right? We'll print result as let's run it, and we get the same for 12, 12, and 8. But if you see, this is order of n square, and that is not efficient. So let's check out how we can optimize it, right? So let's check that. This is brute force approach. If you see this output clearly, what exactly is this? For 48 we are doing 2 into 4 into 6. For second we are having 1 into 4 into 6, 1 into 4 into 6. For 4 we have 1 into 2 into 6, and for this fourth element we have 1 into 2 into 4. Now let's consider this middle elements. I'll redraw it over here so that we can talk about it clearly. Great. Now if you see, for this element, which is 1, 2, 4, 6. So for this, how can we break it down? This is nothing but, for 2 it is 1 cross 4 cross 6, right? For this element, in order to find out the product except that element, we can break it down as 1 cross 2 into 6. Now, what is this? 6 into 4 is the product of elements right of the, right? So this is 2 right and this is 2's left. Similarly, if you see, for element 4, 6 is nothing but the element right of itself and the product of right of itself, and the 1 cross 2 is nothing but product of elements from the left of it. So if you try to generalize it, what we get is result at particular index is nothing but multiplication of left, product of left elements into product of right elements. When I say product of left element, it means all the element except I to the left of it. So product of all the element to the left of that particular element and product of all the element to the right of that element. So let's try to generalize it and code it. See, this is our brute force. We'll comment it out and have a optimized version, that is left, right. It is not a general term, but just for our simplicity we are adding it. So based on what we have found out now, for each element I or index ith, we will be finding product to all the element to its left and product of all the elements to its right. How to do that? We'll check it. For I in range length of nums, left equals to 1, and then for j in range I, because we have to include till that element. Now left into equals to nums of I. We'll print it for our own reference. Print of left comma left. Now right. For right, we'll still have for j in range. Now I have to include all the elements to the right of that element of interest, comma length till length of nums. So this would be right into equals to nums of I. Okay, sorry, it be j, and here also it should be j because we have to multiply that. And now res dot append will do left into right, and then we'll also print this out for our own reference. Right, this is also right, and then print result. Let's check this out. Okay, it should be. As you can see, we have got our result 48, 24, 12, and 8. So if you see, this is more optimized version than the brute force approach, but still we are doing repetitive work here. How? Let's check. For So let's check that out. For this, we have already done 1 cross 4, and then again we are doing 1 cross 4 over here. Similarly, we have already figured out 2 cross 4 here, and still we are multiplying 2 cross 4 here. That doesn't make sense, right? What we need is, we need a more optimized version where we are not repeating things, rather we are holding some memory. So whenever I go from left, I hold my memory as to what has been already seen. And for right as well, I should figure out what I already hold from right hand side. Is there any way to do it? We can try that. Let's say I have a prefix which will hold values when we move forward, and that will include, let's say I'm moving forward from my prefix is 1. So for index 1 it will be 1. For index 2 it would be same. All the elements to the left it is 1. For index 3 all the elements to the left it is 2, and for index 4 all the elements to the left is 4 to the 8. Great. Now for suffix I need the same thing. By the way, this is the same thing as left and right, just we are adding terminology as prefix and suffix. But if you see, if for suffix I have to the right of 6, do I have anything? No, so it would be 1. To the right of 4, do I have anything? Yes, it is 6. To the right of 2, do I have anything? Yes, I have 24. And to the right of 4, do I have anything? Yes, I have 2 into 4 into 6, that is 48. So now result would be 48 comma 24 comma 12 comma 8. Isn't it straightforward? Let's try this out. So we have this a more optimized version with single array because we will be updating the res itself. So here we have res as 1 into length of nums. Let's have prefix equals to 1. So for I in range length of nums, I have res of I into equals to, no, not into equals to. For prefix I'll be only latching to the left hand side, so it would be prefix, but I need to update my prefix as I move forward, so that would be into equals to nums of I. Similarly, my suffix is 1, I'll move forward for, and I'll be checking it from the left right hand side. So for I in range length of nums minus 1 comma minus 1 comma minus 1, because we have to iterate from the right hand side. So now if you have seen here, for suffix, if we have to maintain this, we have to multiply it by already found out prefix, and that is res. So if you understand till here, a res includes all the prefix. So what we have to do is we will have res into res of I into equals to suffix, and I'll update my suffix as into equals to nums of I, and let's print the result, yes, and check if we are successful. Great, it works. So let's try this out. Here and copy over here, and then just return res, check whether it works. Okay, it worked. Final submit. Great. As we can see, our solution is well optimized, and here we have learned from brute force approach how to think and how to optimize it from the everything to the left, everything to the right, finding the product. And here we were in the second approach, we were using two arrays and doing repetitive multiplications, right? So in order to avoid that, we have included this res, which will hold the memory from prefix, and then we can update it using suffix and get the result. So yeah, that's it. Thanks.